get to talk about what we're expecting this next winter. Would like to thank Ed Townsend who helped me put this together, as well as Marilyn Lohman. I didn't put her name on here, but I'll make sure when I send out the slide deck, I'll have her added as well. Certainly very, very helpful putting all this information together. I do appreciate your time as well, taking a few minutes to sit here with us and talk about what winter may bring or what it might not, as well as some of the useful products that you might find helpful throughout the winter season and any upcoming changes. So let's go ahead and get started. So before we begin, I did want to point out, a lot of what I will be showing you today comes from the Climate Prediction Center. And most of you are probably familiar with this webpage already, but they have updated kind of the look and feel of some of their graphics, most notably the seasonal outlook, which you'll see shortly. But yeah, you take that URL there at the bottom right-hand corner. That'll take you to a great resource, lots of information there. And certainly if you're ever having any issues navigating that page, feel free to give us a call and we can point you in the right direction. So a lot of the information is going to be coming from that. Before we start, getting into this coming year, I thought it might be useful to take a look back at last year. And as many of you know, a lot of what you hear about when it comes to seasonal forecasting has to do with ENSO, or the El Nino Southern Oscillation. Last year was a La Nina year, which is the cool phase. It's where the cooler than normal waters off the equatorial Pacific, and that actually has these large-scale influences on weather, most notably during the wintertime across the continental U.S. So last year was the La Nina year, and so this is what the forecast was, the seasonal forecast about this time last year for the continental U.S. And you can see more or less calling for better chances of below normal temperatures and above normal precipitation across much of the Pacific Northwest. Getting a little further south into maybe central southern Oregon, not much of a signal at all. And of course, further south, still they were projecting drier and warmer conditions. So how exactly did that all pan out? Well, lucky for me, in the interest of time helping me put this together, CPC put together a really great postseason verification article. You can find the URL to this article where I got this information there at the bottom left corner of the screen. And so when I share the slide deck with you, you should be able to click on that, or at least copy and paste it into your favorite browser and bring it up. So on the left hand here, the image we have, the left side is the forecast, or the projected seasonal temperature. Again, noting the call for below normal temperatures across the northern tier states over into the Northwest, and above normal across much of the South, the Southwest, Southeast, and Northeast U.S. So the right-hand image there is the actual observed, what we call the temperature, anomaly, how much it deviated from normal. So you've got your near normal there in the gray shading, which, by and large, you note a lot of the country saw conditions near normal over that 3-month period. And again, recall this is averaged out over 3 months. So just because they were near average does not mean they didn't have a cold spell, right? But what you note there is quite a difference from what the projection was. So the northern tier states there actually wound up quite a bit warmer than they were forecast to be. And the southern tier states were much colder than they were forecast to be. And, most notably, the event with the deep freeze down in parts of central and southern Texas that made some huge headlines last winter. And I think you're seeing evidence of that here in this observed temperature anomaly. The only area really in the Northwest that was pretty close was the coastal areas of the Pacific. So Northern California up into coastal Oregon and coastal Washington, where it's pretty well on point. As far as the remainder of Oregon and Washington go, it more or less came out near normal. So by and large, I think they've got a lot of detail about how they calculated their skill score for their seasonal projection. And you can look more into that. But by and large, in a lot of these areas, I think, it's pretty good overall when you consider how far out you're trying to forecast for. Very, very difficult. We tell people as meteorologists that if you look beyond about 3 days, your odds of seeing what's being forecast drop off quite a bit, right? So your confidence starts to fall off. So just think projecting out, 2-3 months from now, what's going to happen. It's very challenging. It's a high bar and high order. So I did the same thing for precipitation as well. And again, on the left-hand side of the image you see here, this is what the seasonal outlook was for precipitation last winter. And what we have on the right, that same image, is what actually happened. And so, we see some similar trends. Most notably, the areas where both the temperature and precipitation outlook really closely matched the observations were in parts of western and northern Oregon and western Washington. And going back to temperature, you see blue on the left-hand side, blue on the right-hand side for those two areas, and for precipitation, green and green. So really standout forecast there. For the remainder of the area, it was obviously quite mixed, but over much of the country, you can see drier than normal conditions as opposed to the forecast, which called for wetter than normal conditions across much of the northern part of the country, and then drier to the south. So what exactly happened there? Well, you can go read that article. I would certainly encourage you to do so, especially considering we are moving back into a La Nina again this winter. But it's important to remember, ENSO, El Nino, La Nina, neutral phase, those aren't the only things that are driving local weather. It's not the only game in town, right? So if we look at just the monthly temperature departure from normal, the temperature anomaly, you see areas on the map here that are red. It was significantly warmer than it normally would be for that month. Bluer, lighter blue, darker blue, those are areas that were cooler than they typically would be. So by and large, all of the northern continental U.S., much of the western part of the U.S., in December and January were both quite a bit above normal in terms of temperatures. And, if you start looking back in time and starting to recall, a lot of our winter here locally in northern central Oregon, south central Washington, it was fairly mild. December, January, I even recall, I think there was a period there where we were kind of noting like, hey, are we even going to have a winter? Because it's just been so dry and it's been so mild overall. And then, as soon as you think that, February hits, right? And you can see the far right image there on this series, far colder than normal across much of the country. And this is when that deep freeze went down into the southern plains and caused all those issues down there. So it's important to remember, seasonal outlook is one thing, but you have to remember, even though you have this long, averaged out seasonal signal, the most impactful weather typically occurs on, periods of days. We're talking 2 to 3 days, maybe 4 or 5, if it's a real active stretch. And so that's what we had in February. If you go back to last February, we really didn't have much winter at all until that President's Day, Valentine's Day weekend timeframe, where it was like 4 or 5 straight days of almost constant snow. I think we broke a record here in Pendleton locally for back-to-back days with 3-4 inches or more snow. So just keep that in mind. We can always have high impact events, even if maybe if we were even forecasting above normal temperatures, we could still have high impact winter weather events. So looking ahead, well, I've already mentioned La Nina has come back. What does the return of La Nina mean for this winter? What are the snowfall trends like in prior La Nina years? And, that'll be a bit of a refresh from last year because we looked at that as well then. What about possibility of mountain snow and what that means for snow melt as we go into spring? Are we going to see higher than normal flood potential? What about the drought? I mean, we're in this like multi-year exceptional drought over much of central and eastern Oregon, central and eastern Washington. We're going to see any relief from that. And we'll also review some of the typical weather patterns we see here in the winter, updates to some of the products and services out there, specifically with respect to hydrology and flood watches and warnings. And just want to throw some general safety information out there and information about how you can get involved. So here's what the outlook is for the El Nino Southern Oscillation. And so what you're looking at here, what I want you to really focus on is probably just those bars, those colored bars. Anything you see that's blue there, that's indicating a La Nina pattern, okay? And the taller the bar is, the higher probability we're going to see that phase continue. So at the bottom here, we have the season, and the way these are laid out, you've got OND, which is October, November, December. NDJ is November, December, January. December, January, February. That's how they do it, these 3-month clusters. And so as you move through time here, you can see La Nina, the blue bar here, is quite prominent with 80%, a little bit over 80% probability right now. And that gradually falls off as we get into, say, February, March, April timeframe. But essentially through the winter months, CPC is forecasting a La Nina event to continue. As we get out into the springtime, of course, probably uncertainty certainly starts to pop up a bit, right? But most of the climate models are suggesting we may move more to a neutral phased event. That's where you see these gray bars pop up. The red bars here reflect El Nino conditions. That's when the waters off the equatorial Pacific are warmer than normal. So by and large, not seeing any real strong signals for an El Nino to emerge, but La Nina and then perhaps moving into a neutral type situation as we get into spring. It's actually much like we saw last winter where we came out of a La Nina, moved into kind of this neutral phase. Now we're moving back into La Nina. So that does happen from time to time. What does the general weather pattern look like during La Nina years? Well, typically we have this very persistent area of high pressure over the North Pacific. And so that causes the jet stream to rise up over southern Alaska and then come down across parts of southern Alaska into the Pacific Northwest. So you get a fairly active storm track that moves off the Pacific. And that does tend to lead to wetter than normal conditions. But you can see the signal for, much colder than normal conditions is typically shunted further east. So more like the Northern Rockies, Northern Plains, perhaps down into the Central Rockies, where you see these intrusions of Arctic air. Now keep in mind, this is an averaged out pattern. So if you were to shift that high further offshore, your jet stream would move further west or move left in this image. And then you would perhaps open the door to some of those Arctic air events moving into the Columbia Basin and the Pacific Northwest. And so that does tend to happen from time to time, right? That's what gives us our most impactful low elevation snow events, not only here, but even west of the Cascades where they don't commonly see as much snow. As far as temperatures go, there's generally not a real strong signal with La Nina, but there is a stronger signal with precipitation. So here's the drum roll, please. I can't do drum rolls very well with my mouth. I just wasn't blessed with that talent. So I'll just knock on the table. But essentially, here's what the winter outlook is for this coming winter, the December, January, February timeframe. Interestingly, should look quite familiar. It's very similar to last year's. We see better odds of below normal temperatures from Oregon into Washington over into the northern plains. Above normal temperatures pretty much everywhere else. As far as precipitation goes, a similar pattern where we see greater likelihood of wetter than normal conditions from Washington over into Montana. And it kind of drops off as you move further south. So again, calling for a cooler than normal, wetter than normal winter as compared to normal. So does this mean we're going to have tons of snow? Well, just because you're going to be wetter than normal doesn't necessarily mean you're going to be snowier than normal, right? And we'll get to more of that here in just a little bit. Before I do, though, I would like to talk a bit about the drought. So this is the drought monitor as of last Thursday. There will be another one released tomorrow, I believe, that come out every Thursday. So this image you see here is not taking into account any of the atmospheric river event that we had, the rainfall that we got in the prior week. I would expect there probably will be some improvement, especially across California. Some of those areas picked up 5 to 10 plus inches of rainfall. Of course, getting it all at one time is not necessarily helpful for the drought, but I would expect there would be some changes from the last outlook. But nonetheless, doubt there's going to be significant improvement in the areas where we see exceptional drought, and that extends across south central, southeast Washington, down into central Oregon, all the way down into central California. And this has been kind of a multi-year thing. We've had this drought that's gradually gotten worse and worse with time, as we just haven't been able to catch up on that precipitation deficit that we've seen over the last several years. So what is CPC expecting? So what we're looking at here, this is an image that shows drought tendency. So the areas where you see yellow, they're expecting drought will likely develop. The areas where you're seeing brown are areas where the Climate Prediction Center is calling for drought to either continue or perhaps get worse. The areas we like to see are kind of that tannish, off-whitish, khaki color, which would suggest we may see an improvement in drought conditions. And the areas in green are where the Climate Prediction Center expects that we'll actually see drought end altogether. And no surprise, based on that seasonal pattern where we, likely will see a lot more precipitation along the west of the Cascades, that's where the Climate Prediction Center is calling for the drought to end through the season. As far as the khaki area go, you can see it extends over a large area. It's all going to depend on how many storm systems we get, how active the storm pattern is. For example, if we end up with a pattern through December, January, February that is similar to what we've seen over, say, the last month, that's a pretty active pattern. So we're probably going to see a lot more precipitation, not necessarily snow in the low elevations, but at least more liquid, and that would likely lead to greater improvement in the drought. Marilyn actually put these two in there. This is kind of an interesting way to look at things. So this is the projected polymer hydrological drought index. The image on the left is what the drought index would look like if we end up seeing normal temperature and precipitation through the winter season. So if we're just kind of near normal, we just wind up with kind of the normal amount of precip that we would get in a typical winter time. The projection is that we're still going to see drought across at least southern central Oregon up into southeast Washington. On the right, the image is what would happen if we see a wetter than normal, a cooler and wetter than normal winter. And in that case, you can see that we're seeing, rather than these kind of brownish color shades, which indicate persistence of drought, we're kind of seeing more of the non-existent lighter shades, white, even some light greens as we get into parts of eastern Washington, down into California. So this is why, with this La Nina especially, I think we're kind of hoping, even though it does make it a bit busier and maybe more active at times, we are hoping to get a bit more precipitation so we can really erase some of this long-term drought and start to improve. And so this is what we would be looking at. Same for the previous. This is projection through February. This would be the projection through May. So this is actually taking us all the way into next summer. So again, if we're looking at kind of normal temperature precipitation, see there still will be some improvement, although we're still seeing some lightish orange shades, which means that we'll probably see some persistence of drought. But if we do get that above normal, wetter than normal seasonal rainfall precipitation, you can see we will see a fair amount of improvement. So just an interesting way to look at it. It's kind of how much rain in addition to what we normally get will we need to really erase this drought, and it's going to be a fair amount. So we're just going to have to see what happens. The best news, I guess, is that because it's a La Nina year, we can hope that we probably have a better chance than we might normally have. Okay, the next few images I'm going to show you, they come from a new tool that I was actually just playing around with today. I thought I would just throw some of these in here. It's a local climate analysis tool, and I'll throw a URL up here in just a minute, a separate slide on that. So this is looking at precipitation, seasonal precipitation for Pendleton. This is the Pendleton Airport. And the series of bar graphs you see here, the two on the left are for La Niñas. I could have just put, instead of ONI, I could have just put La Nina. Anytime you see ONI less than 0.5, that's a La Nina. It's negative. It's cooler than normal sea surface temperatures. The neutral phase is in the middle there, those two bar graphs. And then on the far right, those are the bar graphs associated with our warm events, or the El Niños. So this is just 3-month average precipitation. And what we see here is, when we look at just the Pendleton Airport, and I'm not going to show every possible location because I don't think y'all want to hear me talk for that long, and it would take a really long time to go through everything. But when we just look at seasonal precipitation just for the Pendleton Airport area, we see our chances for above normal precipitation are greatest during those La Nina years. So 59% versus below average or below normal would be 40% during La Nina. So the left two graphs here. Neutral, you can see, is kind of a coin toss, 50-50. Interestingly, and I was a bit surprised by this, for the warmer events, El Nino events, there's about a 56% chance of above normal precipitation there as well. There really, again, is no signal in neutral years, but there's a lot of variability with precipitation, especially as you get east of the Cascades. So let's apply the same exact logic to our seasonal snowfall and see what that does. So interestingly, we see for all phases, La Nina, the two bar graphs on the left, the neutral phase, and El Nino, the two bar graphs on the right, we see a better chance of snowfall below the 30-year average. Although I will state none of these are statistically significant. And the greatest chance of seeing below normal snowfall does happen in El Nino years, which is actually consistent with kind of the average pattern we see El Nino events. So what is this really telling us? Well, it's telling us that if we look at precipitation by itself, there's a bit of a signal there, right? We see better odds of above normal precipitation with La Nina events. When we look at snow east of the Cascades, it's a giant question mark. It all depends on what the weather pattern looks like at the time. Do we have enough cold air? Do we have enough moisture coming in? Do we have enough moisture that's actually going to get to the ground, or is it all going to evaporate before it hits the ground? Those kinds of questions are all part of whether or not we're going to see, especially low elevation snow. With La Ninas, there tends to be a better signal, and I couldn't find a good station to show this, but there tends to be a better signal for mountain locations picking up on more snow versus the lowlands. So just something to keep in mind. And, I thought it'd be interesting, too, just to pick a couple locations on the west side of the Cascades. So this is the Portland Airport. And again, we're looking at seasonal precipitation, not snow, not just snow. This is all precipitation on the west side of the Cascades at Portland Airport. So again, that's pretty similar to what we saw in Pendleton, where we have chances of precipitation being greater with the La Nina events at 59% chance of above normal precipitation here. Neutral, 50-50, and then El Nino still has a very, very slight positive for above normal as well. If you move further north, though, this is kind of interesting to me. This is Seattle-Tacoma Airport. You see the odds of wetter than normal conditions actually go up quite a bit in La Nina years. So whereas 59% in Portland, it's actually 63% in La Nina years, with only about a 36% chance of it being below normal for precipitation. So that was kind of an interesting thing to note. And perhaps that makes sense, because we saw that overall pattern, what that looks like. And the way the jet stream is oriented, you would expect the further north you get along the Pacific coast, even up into Canada, you probably would see a lot more precipitation. So this seems to be consistent as well. So just quickly, local climate analysis tool. This is a relatively new thing. It's still under some development, but they are giving some limited access. So if you're doing any kind of climate study, or you want to look, within your local area at what the climate signals might look like, depending on whether you're in an El Nino, a La Nina, a neutral phase, so be it. Visit the URL there. You do have to create an account, and that account has to be approved. So, I don't know that everybody should jump on there. It takes a little getting used to as well, but certainly a very valuable tool. I'm still playing with it and trying to figure out the ropes, so to speak, but it's been kind of interesting to assess some of the different locations across the region. So main takeaways, as far as our winter outlook goes, I'd say our confidence is kind of low to moderate, that we'll see temperatures come in below average over the entire season. Again, you go back to last year's outlook, right? Most of the areas across interior Washington and Oregon really ended up close to normal, near normal. I think there was a small part of Eastern Oregon maybe that was slightly above normal. But really the below normal stuff was kind of mostly west of the Cascades. Confidence is moderate, though, that we will see precipitation come in above average. But again, it all depends on how active the pattern is. The El Nino Southern Oscillation is but one climate circulation that's out there. there are other climate oscillations that affect weather across the United States as well. The Arctic Oscillation, the North Atlantic Oscillation, there's all of these things, all these pieces, and extremely complex to say that this one is going to be the only driver. But it does tend to have, the strongest correlation to some general seasonal pattern. So that's kind of where we're at with that. We are very confident that we're going to see episodes of heavy mountain snow, moderate to heavy lowland snow at times, but just how many we see and just exactly when they're going to happen, big question mark, right? And of course, as always, depending on what kind of snowpack we have, we may see a higher risk of snowmelt flooding. Certainly, if we end up with a rain on snow event, we've got a lot of snow in the mountains, we're going to be really looking closely at our flood risk. But right now, it's far, far too early to speculate. I will say the beneficial rain we had the last few days, did lead to some subtle river rises, but we really are looking at kind of historic lows on our stream flows. So it's going to take a lot to get us kind of back to that normal, and then even more to get us, to push above the flood stage. So that's something to keep in mind as we move forward. One thing I did want to cover really quickly, part of the hazard simplification program, that's kind of been a multi-year program to go in and look at all the different hazards that we have in the National Weather Service and try and streamline and make those more efficient. There's a fairly big change coming to our flood watches, warnings, and advisories. And this will occur on November 16th. So that's coming in the not too distant future. I guess we're just about a couple weeks out, maybe 3 weeks. And essentially what we're going to be doing is doing a lot of consolidation. So you can see there the flash flood watch, and flood watch will just become a flood watch in most cases. All these different advisories, urban and small stream, arroyo and small stream, flood advisory, small stream, all that is just going to become one flood advisory. And then finally, we're going to be reformatting some of the text in these products as well. So as opposed to having, if you've seen a flood advisory or flood warning come out, a lot of times they're very text heavy. It's a lot of paragraphs. So we're going to move to a format that's much more easy to interpret. That will include kind of that impacts-based format, right? The what, where, impacts, and additional details. There is one caveat with the flood watch. That's why there's a fun little star here. If we expect conditions, for example, if we have possibility of a dam break or a levee failure somewhere, or we assess there might be a potential for flash flooding on burn scars from the large wildfires that have happened over the last year. In those 2 cases, or 3 cases, we might choose to go with a flash flood watch specifically because there are specific conditions that could lead to flash flooding. But otherwise, more or less, we're going to be seeing primarily flood watches. So just wanted to bring that up for your awareness. Something else that's in the offing, and when I say offing, I mean it's like years down the road. The word advisory is not going to be a thing at some point. We're eventually going to be doing away with advisories, but there's going to be a lot more information to come before that actually happens. That's why I say years. It's going to take a while to get there. So just something to be aware of. Wanted to quickly just run through kind of our typical winter patterns, our impactful patterns. So a very common one, and we've seen this just in the last week, right? A big storm system comes in off the West Coast. We see a stream of moisture come up over the Cascades and, up into parts of the northern U.S. And what this typically leads to a lot of times is low elevation rain, because usually air temperatures aren't quite cold enough to support snow, but we do see mountain snow pretty frequently, right? I think we have a system coming in the next few days that is going to be like this. Not projecting extreme snow right now, but it does look like northern Washington and western Washington and the Cascades could pick up some pretty hefty rain and possibly even some snow. So this is a very common pattern for us in the wintertime. It's one of those that gives us the beneficial rainfall without a lot of the low elevation snow impacts. So, can be kind of nice to ease into winter. The one that's more impactful is usually after you have that first system go through, a strong front will come in and bring this Arctic surge of air southward. And a lot of times it kind of just rides the east side of the Cascades. Sometimes it bleeds over west of the Cascades too, just depending on what the source region is and kind of the orientation of the front. But this is where our real high impact events come to all elevations, right? Not just the mountains, but also the gorge, the Columbia Basin, all the valleys and everything else. You get that cold air in place, and then you have this fetch of deep mid-level moisture that comes up and over that. And you either end up with snow, or if you've got a little warm air aloft, you can end up even with freezing rain. That's always fun, right? So this is a very high impact pattern here. But it does take a fairly strong system to move through in advance, because you've got to get the cold air in place before you have the possibility of snow at the low elevations. And one that a lot of people forget, and I always mention this is a repeat from last year and maybe even the year before. Just because you got high pressure doesn't mean that it's always quiet and fun and pleasant. When we get high pressure, especially from late November through about mid-February, that's when we start dealing with air stagnation. And a lot of times we'll get persistent day after day, if the thing isn't moving, low clouds, stratus in the Columbia Basin and the gorge, and sometimes freezing fog as well, just kind of depending on the situation. And, freezing fog for one day is kind of a pain. Freezing fog for 5 days is bad, because then it starts to accumulate and accrue on road surfaces and sidewalks and everything else. So just because we have high pressure in the wintertime does not mean it's going to be quiet. If we have, a few systems coming through and we've kind of got high pressure either to our east or west, sometimes that can keep us a little warmer than normal, but you've got to have something to mix the air up so it's not just sitting there and cooling and saturating. That's the problem. That's where we get that fog from, the low stratus and everything else. A couple of products that you might want to take a look at as we go through the winter. This is the Winter Storm Severity Index. I have mentioned it before, and it's still, I think it's not in development. I mean, it's still experimental though, and they're kind of looking at how to better capture impacts due to winter weather. So instead of kind of just looking at one element like snowfall, they're trying to take into account a number of different aspects. I think I have them listed actually on the next slide. Yeah. So they're looking at snow amount, snow load, possibility for blowing snow, ice accumulation, flash freeze, and then ground blizzard, which we don't tend to get those last two terribly often. But it tries to kind of give a composite risk index in capturing all of these different elements, and has this nice scale that goes from limited to minor all the way up to extreme impacts. One thing I will point out, you'll notice right offhand here, and this is from October 25th this year, so pretty recent. But one thing you can note here is the peaks of the mountains stand out, right? I mean, you see major and extreme impacts. We know people aren't living up there, right? So, I mean, the real impact would probably only be on any recreational folks that happen to be up there. But that's one of those things that, because it's in development, they're looking at, to see, well, do we need to somehow mask that or refine it or figure out a way to account for that. But it certainly is something interesting to monitor, even in the low elevations, because, again, it's kind of based on climatology and what kind of snow thresholds and things, how they vary across different geographic regions. So what 4 inches looks like in the mountains shouldn't look the same in the basin. It should obviously stand out more. And we'll have to take a look at that through the season. A few other tools. One I like to mention is the probabilistic snowfall graphics. If you go to that URL at the top, the weather.gov/pdt/winter, you'll be greeted with a series of images and a table that spits out probabilities for different snow amounts. I'll get to that in a second. The first 3 images you're going to see are the snowfall forecast, which is the most prominent image on the left-hand side. I think this is from last year, so you can disregard the date, obviously, but it's just for demonstration. The graphic on the upper right-hand is going to be the 1 in 10 chance. So that amount of snowfall has essentially a 10% or less chance of happening, but it counts as what we would call a reasonable worst case scenario, okay? So for planning purposes, for resource positioning, for hopefully making better decisions or giving you information that helps you make better decisions, we've been told that that worst case upper, 10% or less chance of happening is a good amount to go on. And then the bottom right image is the 90%. So has at least a 90% chance of happening. And that would be kind of your lower end snowfall amount. There are also a series of images that have probabilities for specific values of snowfall, from 1 to 2 inches all the way up to 12 inches. I think it even goes higher than that. But these are really nice because you spit out a probabilistic. So for example, here we've got a percent chance of 1 inch or more snow. And as you would expect in Tri-Cities, it was 0% on this day. This is October 23rd, 2020. But as you got up toward Ellensburg and into Snoqualmie Pass, obviously the probability of that increased. Probably had one of those storm systems coming in from the ocean where low levels were fairly warm, but we were getting precip, so we ended up getting some snow. There's 4 inches of snow or more for the same event. So it's kind of nice. You can compare those two, and so on and so forth. There's also a table view that just kind of summarizes all of that data in one spot for specific locations. I believe there is a way to add additional locations to this table as well. So as you're going to that page and assessing, some of the different locations, and you're interested in adding one, get with me. We'll see if it's possible. I have some connections. I don't know how easy it is, but we can at least investigate, okay? What about winter safety? We always want to push safety, and we want to provide you resources where you can easily grab images, throw them on your social media page, put them in an email, whatever it is. Email your staff, email your students, email your management team to make sure they're aware of any incoming winter hazards. For that matter, once we're out of winter, any fire weather hazards, severe weather hazards, anything that you would find useful. So we have seasonal safety campaigns. Obviously, we're in the middle of the winter right now, so that's the one I'm highlighting here. But if you just look up NWS National Safety Campaigns, it should come up with a page that shows you all the different seasonal campaigns. And the Weather Service has a team of graphics experts, and they have come up with some fantastic content. It's very easy to grab. It's very easy to share. And there's even a lot of the resources that are there have actually been translated into Spanish as well. So if you have a large non-English speaking population that you serve, we can also, usually get the same graphic in Spanish. And if you want to work on or collaborate on a specific tailored message that has to do with weather that's in Spanish, there's also a translation team with the National Weather Service that can help do that. So if that's something you're interested in, my email's at the end of the presentation. Please feel free to email me. I would love to work on something like that. Weather support for events. So we don't have a lot of events in the wintertime. It tends to be colder, darker. A lot of people go inside for a long time and hibernate more or less. But for the events that do happen, we know weather can be very impactful. COVID-19 is still alive and well, and we know a lot of support that we would provide would be in the form of either a virtual briefing, a phone call, something or other of that nature. But occasionally, if you really want someone there and it's mission critical to have someone on site, say a big storm's coming in, you really want that in-person expertise, we are certainly open to that. So there's a phone number there that you can call the office. You can obviously email me. And there's also this Google form you can use to try and request assistance or request some form of support for any kind of event. We also encourage anyone and everyone to become Weather Ready Nation ambassadors. I think I sent an email blast out about this. It's probably been a few months now. But I thought let's throw it in this presentation too and see if we have any more takers. The Weather Ready Nation Ambassador Initiative started several years ago. There's a series of really big tornado outbreaks in the plains and the southeast that killed a whole lot of people. And, we found, the Weather Service and NOAA found that the best way to try and, get around that is about community resiliency and response and preparedness. And the best way to do that is to empower the local organizations and agencies in those communities with information. so they can share that information and folks know how to better protect themselves and their families and their property. And so they came up with the Weather Ready Nation Ambassador Program. So I would strongly encourage you to take a look at becoming an ambassador if you aren't already. We have a lot of great ambassadors out there already. What it would entail essentially is an email address. There's no real commitment beyond that. Once you put your email in and you sign up to become an ambassador, you're demonstrating you're committed to weather safety and that you're committed to protecting those that you're charged for caring for, whether it be your staff, other managers, just general folks in the community. And then we'll have some seasonal email messages that will go out that provide preparedness information, and they're always seasonally relevant. So I think there was one that went out recently that specifically dealt with winter hazards and things of that nature and pointed to the winter safety campaign. But it's great. It really arms you with resources and also gives you rights to use the Weather Ready Nation Ambassador logo. And you could even have, a great picture like this one on the right side of the screen here with me. All kidding aside. There is also part of the ambassador program, a Weather Ready Nation Ambassador of Excellence. That is a program where we honor one of our ambassadors with a little summary, showing that they took extra, kind of went above and beyond what just a normal ambassador would. So if you go to the Weather Ready Nation Ambassador page there, weather.gov/WRN, there's a link to a map, and you can view the ambassadors of excellence for this year across the country. The one we chose for this year was the Hanford Meteorological Station. We chose them because they've worked very closely with us, over the years, for one, but pushing out safety and preparedness information, and also investigating some of the extreme heat that we saw there at the end of June. It got extremely hot up there. So just, one example and another pitch for you. If you have questions about the ambassador program, do not hesitate to reach out to me by email, by phone, or just the office, and they'll point you to me. But definitely would love more people to get involved in this. There's a bunch of links to additional resources. This is primarily just for the slide deck itself. So as you go back through and you want to figure out, what is it that he was looking at and how do I get to it, there's all the links there. And that pretty much is a wrap.